Ladies and germs, welcome back to this lovely episode 3 of Electronics with Alcohol. I have a Bacardi with Bionade, which is actually pretty good. I'm not disappointed at all. What I'd like to talk to you about today is the use of a program called Arduino. Arduino is well known, and it uses C programming language to create its sketches to program all kinds of devices. In this case, what you see on the screen is Arduino. I use it specifically to design software to be compatible with the ESP series chips, the ESP8266 chips. I specifically use the ESP12F and the ESP07. Those are the two chips I now use. I recently got some ESP32s, but have not delved into that realm because they are very intricate and very difficult. The documentation on them is very scarce, and it's yet to be developed. So I'm going to put that to the side for now. But what I wanted to talk to you about today is a software that is developed by these guys at letscontrolit. It's ESP Easy, and what it is, it's basically software that is used for the Arduino platform to upload to your ESP07s. Now, I'm going to show you multiple different type of ESP chips that I have with me. Let me pull these out of my hat. 12, 3, 7, 32. Oh, this is on here. These P's. Nope. So, what we have here is I have an ESP07. So, this chip right here is one of the basic chips that I use for most of my IoT development platforms. It has a few pins that you can use. There are pins that you have to terminate for upload and for normal operation. But in terms of size and compatibility, these things are great. I mean, if you look at the very top here, there's an antenna port. And I use this chip for pool control. The pool pump and everything is outside, and my Wi-Fi hotspot is kind of not very close to the actual chip itself, but it works great. I love it. This is an ESP03. I don't use these much because there's not much you can do with them. It does have an antenna, but it's usually used for connecting to. It's not used to connect within a network to turn on and off devices. It only has 5 pins, and you might, I don't know if you could probably get an input-output from these, but I don't use them as much. I've got, I think, like 2 of them on there. This is an ESP12F. And if you notice, the pinouts on the sides of them are the same, but if you look down below, I've got cables connected to the bottom of them. Those are S-Clock, MOSI, MISO, and then you've got GPIO 9 and 10, and a CS0 for the designator for the pin. And these work really well because the onboard antenna is a little bit more precise, and it's tuned for longer ranges, so you don't have to use an external antenna. This, what I have in my hand here, is an ESP32W Room, or Room. I don't know how they call it. Let me see if we can take it out of the package. Come on out of there. This is a huge chip. It's comparable to the 7, but it's wider, and the breakout is really small. It's very hard to see on camera, but it's extreme. I mean, really extreme. You look at the back of it. I mean, the pins are just so small. I have to use my heat gun or my heat soldering iron to do the actual soldering to the plates to get it to work right. You can use a conventional soldering iron, but it's very, very tough to get those pins to where the solder doesn't cross over. So that being said, let's go ahead and jump into Let's Control It. These guys have done a wonderful job on the software itself. Currently, the ESP Easy is at version 120, I think, and it's a really good piece of software. I've been using them from day one because when I started programming this stuff, I was like, you know what, there's got to be an easy way to do this. And I was like, fuck it. So I started searching on the internet, and I found these guys, and they had just done a hell of a job doing it. So if you look at the ESP Easy website and you go into the actual the wiki, go up to ESP Easy, and it's got a buttload of stuff. Buttload of stuff. So let's go ahead and see what kind of hardware they got. So let's go in the easy introduction and just scroll down. And what you've got is all these different applications. You've got pulse counting, Dallas. The DS18B20 is one of my pinnacle pieces of equipment. I love this thing. Even though I must put a caveat on there. The guys at Fritzing, the actual board layout, it's backwards. I've fried about 5 or 6 of these things trying to figure out what the hell is going on. But they fucked it up and they turned it backwards. So I didn't fix it, but you know what? I just adapted. Just adapted to some saying. So, and then they've got the DHT. They've got the DHT12, DHT11, and DHT22, which are all compatible. It's selectable in the hardware. Distance, switching, which I'll show you in later videos, and then analog signaling. The MCP23017, great piece of hardware. That's a great IC. It uses the I2C bus to control up to 16 different input-outputs. Could be a switch, could be DS18B20. If it's a digital signal, then it will be able to process it. One of my other favorites is an infrared receiver. Hands down, one of the greatest things. Great to control air conditioners. You just have to tweak the software just a little bit. So here's your outputs. You can do IRs, you can do LEDs. Relays is one of my favorites, which I use a lot. And then you've got your others. You've got your LCD and your OLED. Inside of the software, they got this built into it to where you've got these screens that you can basically program to show information for the user. And if you look down here at the bottom and this OLED, this is an actual OLED that I showed you earlier in the video in episode 2 that I was using for my controller down in the basement. Even though there's a lot of information on this page, I really don't like the fact that there's not a lot of in-depth information. They do have the breakouts on how to use the stuff, but when it comes down to the nitnoid type programming of the actual process, it's just not there. And it's taken me a long time to actually try to figure out and be successful on getting this stuff to work properly. And that being said, it's still really good. Now I must caveat that some of the ESP boards, sometimes the pins won't work as well as you think. Some need to be a pull down or a pull up, or a high or low pin, which means it either goes positive or negative to trigger the device. If you have it backwards, sometimes, especially if you use pin 16, if you trigger it low, what it'll do is it'll just reset the ESP. Now, you don't want to do that, because once you reset the ESP, guess what? It basically just resets itself. It keeps resetting itself until it just can't reset itself anymore, which makes it unusable. Then you have to reflash it, blah, 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 same thing over and over. But they've done a really good job on the software. But to use this software, you have to have the Arduino software installed on your PC or Mac. And the settings are pretty much straightforward. They go through some the guys at ESP Easy, Let's Control It, they go through some simple steps to get the Arduino set up properly. There are some items that you need to set up initially to get it to work, and I'll show you some of those that I've done just to get the ESP Easy to work properly. Now, that being said, you need to have a RS-232 serial programmer available to you when you want to flash the ESP07s and 12s. And I'll show you that in future videos just to give you a feel of how to do it. So if you look at here, this I've already gone ahead and built my ESP7 and 12s. And if you look at it, the top part of the first tab of the ESP Easy, it's just user information. And what they've done is they've parsed off the user information portion to the actual programming portion. So the only thing you need to do as a user is you go into here and you go to this portion right here. This is where it starts. You put all of this information in. So for instance, I was testing a new sensor, so I put sensor 6 as the name. There's my SSID. There's my my passkey. There's the IP address of my domestic server that I use, and then I've got the actual IP of the device. And to use static, you have to put default use static IP true or false. If you put false, your DHCP server will assign an address to it, and then use the sensor 6 as a DNS name to resolve to the domestic controller. I don't recommend that because, as you know, DHCP addresses change, and that could cause a lapse in your service if you've got something that's critical on your network. In most cases, you probably won't because this is all just home stuff. And then you've got default MQTT template. We're not using MQTT right now, but so we put false. More information on MQTT can be found on mqtt.org. I don't use it because it's an external interface or a broker. I don't like using brokers because they're outside of my firewall. Anything outside of my firewall is bad. So when I use default protocol, I use one, which is the domestic HTTP, which you've seen in episode 1, my whole framework of my controller. That is my broker. So then you go down here, and after you get to a certain point, you see this. Do not change anything below this line. Now, if you're an expert in C, in any C language, then yeah, sure, go ahead. Mess around with it all you want. But, caveat, your shit won't work the way it's supposed to. Guaranteed. I've already tried. I've made a few changes to the stuff because I wanted to modify some of the controllers, and it just gets sticky because if you look up here, there's so many different tabs that you have to go through. You really need to know what you're doing. If you don't, just forget it. Just step back. Just let it go. Anyways, the actual flashing process is quite easy. It takes about, I'd say about a minute or so to get an 07 flashed or a 12, depending on what size memory you have in there. But when we flash a chip, either the 7 or the 12, right here is a 7. The 7 has a 1 megabit memory, or one megabyte? 1 megabyte memory. And then the ESP12 has a 4. And you have to partition that off correctly because if not, you won't be able to do much movement on it. So if you look at here, you go down to Tools. This is one of the module libraries that you have to load into the Arduino libraries within the Boards Manager. There's a lot of different settings you need to go through, but as I said before, once we flash one, we'll go from step 1 to step infinity, how many ever steps that is, to show you how to flash these properly without having a problem. You also have to make sure that the breakout board that you have connected to these ESP boards is correctly wired, because you can't just hook this thing up and then just flash it. It just doesn't work that way. You have to have a certain amount of resistors on it. You have to have capacitors on it. You have to reset certain types of power. You have to have 3.3 volts, and it also has to have capacitive power on it to make sure that there's no spikes in the voltage. There's a lot of different aspects that you have to worry about when you're flashing these ESP boards. There's a lot of information out there to find out what exactly is the best. I will tell you what I have used because I have gone through about 20 or 30 different setups, and I've found that the one that I'm currently using is about the best one. With that being said, look through the ESP Let's Control It website. They really did a good job. I got to give them hands down. Their wiki page, there's a lot of people on it. I mean, you look through the general discussions on Let's Control It, and they've got so many people working on this stuff because it's something that IoT has been lacking. It's something that every person can do. They just have to have a little bit of know-how and a little bit of want to know how to get this stuff done. And once I do that, be good to go. But in future episodes, we'll get to that. But in the meantime, we'll stick to the software piece and go through. But I'm hoping that soon we'll be able to sit down and flash one of these things for you. In the meantime,